Want to pass the CKA exam? Here's the first thing you need to do. Go hop inside of your time machine and travel back before February 2025, when it was much easier to pass. So in February, we took all those topics that we were supposed to know already and bam, threw some more on top of that. Not gonna lie, this new stuff is tough. So what's new and horrifying on the CKA exam? So glad you asked. It is either brand new topics or it is an increased focus on topics that you are very unlikely to encounter on the exam. Specifically, we're seeing autoscaling, horizontal pod autoscalers definitely being a topic of interest. StatefulSets, whether you use them or not, will likely be on the exam. We need to know about node affinity, selecting nodes, which would include things like taints and tolerations and things like that. And regarding configuration and package management, Helm, though it is a third-party tool, is something you should expect to see on the exam. And then there's this new tool, Kustomize, that you need to know how to use. We've also got more security and admission requirements, such as pod security. We also need to know about pod admission, so limit ranges specifically. We need to know about node level isolation, so how can we keep pods on specific nodes? So again, there's taints again, plus some other things. And much more stringent storage. Storage has always been a big part of your grade on the CKA exam, but now we are moving into more advanced stuff like dynamic volume provisioning, also being able to create storage classes, and inside of your persistent volumes and claims, being able to define volume types, access modes, reclaim policies are definitely now the norm in the new CKA. What's also new is some stuff regarding networking, and this is in addition to all the things we were already supposed to know about it. CoreDNS. There is a much higher focus on troubleshooting in the new version of the CKA. Expect to encounter issues that you have to deal with in the CoreDNS. Plus, CoreDNS is supposed to be configurable. You may have to make some configuration changes. Plus, there's this new hotness, gateway APIs. You will be asked questions about that one. You can not count on expecting to see etcd backup and restore questions, but that's pretty much the only thing that's not included. Now, all the other stuff that's not new in the exam can be found inside of this excellent video, which we posted a little while back. But for all the new questions that you may get, here are 14 examples, including the solutions that will show you how you can beat this CKA exam. Are you ready to crush it? 'Cause here we go! Here we go with our first task. Let's start off with storage. And this is going to be on the easy side of the storage questions you're going to be asked. Standard question, we need to create a persistent volume claim of a certain size, a certain access mode, and using a certain storage class. We are not being asked to make a persistent volume. That should be created dynamically. That storage class that we're using, we don't have to create for this one. It will create a persistent volume for us. But we also need to create a pod that mounts that persistent volume claim at a specific path, and we need to verify that the volume is automatically created and mounted. All right, so let's get down to it. So like I said in the other video, you are allowed to use the Kubernetes IO documentation, and you will need it. My advice is be very proficient at finding the manifests that you need for the types of objects that you need to create. For all the manifests that I'm going to be editing, I'm going to be just copying them straight out of this documentation. So I'm going to search for persistent volume claim. Of course, you're going to get the persistent volumes page as a result. And what you need to do is that you need to scroll down through until you find a persistent volume claim that matches what you need. Now, what's also nice is that there will be pod manifests inside of these particular pages that include an already mounted persistent volume claim inside of it. I'll be copying and pasting this for later. Let me zip on down through. There you go. Find one that's as close to what you need as possible, then copy and paste that bad boy, and I'll see you back at the command line. All right, so here we go. Once you found a manifest that's close to what you need, hopefully it's as easy as filling in the blank, like so. All right, so you can see where we've placed all those values that are being required by the task down inside of our manifest. So what we're going to do is we're going to go ahead and we are going to create that object. Now, always verify after you have created all of these different objects, right? So right now, this is in a pending status. If we wait long enough, that will change to bound because the local path storage class is dynamic and that should be created. But we still need to do the next part of the task, which is we need to make this pod that's mounted at that particular location. So again, let's go back. Let's grab that manifest that we were looking at inside of the persistent volume page and paste that in here. There are a few things that we can safely take for granted in what you'll be asked to do for a task like this. That if we need to run a specific image or give the pod a specific name, that information will be provided. But where it's relevant to what we're doing with storage is that we do need to know how to add persistent volume claims as volumes and how we can mount those persistent volumes as volume mounts to our containers. So you can see we're mounting at /data, and we should be able to create that pod at this point. So always verify, of course, after these things have been created. I can see that my pod is in a pending status. These things aren't instant, which can be kind of spooky when you're working with these storage labs. And there you can see that it's running. If we want to check what the state of our persistent volume claim and our persistent volume are looking like at the moment, you can see that there is now a persistent volume. It was created because we had a dynamic storage class. And that should be everything that we need in order to satisfy this task. All right, so here is definitely a more difficult version of the question that we got previously. Now we're being asked to actually make a storage class ourselves using the criteria that you see right there. And then we need to create persistent volume claim and volume that use that storage class. That said, let's get down to it. What manifests are we going to need to accomplish this? And there it is. Storage class manifests are not terribly long, and it's really a case of copy and paste. The volume binding mode immediate means that when we create this persistent volume claim, it should immediately bind it to a persistent volume. It's not going to wait until it gets attached to a pod or anything like that. And here's our persistent volume claim, almost identical to the one that we made inside of the previous task, except this time this is only going to work if we made our storage class correctly. 2 control applies later, and we've got both of those objects created. Let's check and see what our persistent volume claims are looking like, and nice. Looks like they are bound, they are set up with the correct storage class, and we are good to continue. While again there is a focus on dynamic provisioning, you should still be aware of how to manually provision as well. So for our last storage task, we're going to make one more persistent volume. This one is going to use a host path to a specific directory, which we'll see when we start doing the actual task itself, with a specific access and retainment setting. Then we're going to need to make a persistent volume claim that binds to it. So let's start with the hard part, making the persistent volume. And at a glance, you can see that this persistent volume is being created with several of these parameters in mind already. Capacity storage, access mode, and reclaim policy all are stated explicitly and manually inside of the manifest. Now, in the new version of the CKA, you're going to see these big, ugly node affinity that we need to add. And what this is simply saying is that we are requiring that we match up with a node that matches the following expression, where the key value, if the key value pair that represents the actual node itself, Kubernetes IO/hostname, where the value is in this list of values, there's only one listed there, node 1. So this is going to make certain that we go to any of a specific list of nodes, but obviously it's just the one that we want to go with here. And down there at the bottom, our host path. That path should already exist inside of the node. If it doesn't, it is a simple question of just copying it and being able to SSH inside of the node in question, and then just making that directory inside of it. You should have SSH access and root access to all of the nodes inside of your cluster. And here's our persistent volume claim. Now, not to play it fast and loose with the exam, you will be told explicitly what the names of these volume claims are supposed to be, whether they are even supposed to belong to a storage class. We don't need to because it's not specified, and what amount of storage it's expected to use. But the one thing that we do want to do, because we want to make sure that we're going to this persistent volume explicitly, is to call out that volume by name. Now that that's done, let's go ahead and let's create both of these objects. Let's give them a sec, and then we'll check and see how we did. All right, so yeah, little ugly, but you can see it wrapped around my screen here that this is successfully bound to the persistent volume that we made, and we can see that that persistent volume down here is the correct capacity, access mode, and everything else that is required of us by this task. Autoscaling. So what we're now being tasked with is that we need to take an existing deployment. You may be asked to create the deployment yourself, but that's relatively simple, and we're not going to include that in this demonstration. What we need to do, though, is we need to configure a horizontal pod autoscaler to scale that deployment from 1, which is its default, up to 5 replicas when the average CPU utilization exceeds 50%. Let's grab a manifest off Kubernetes IO, and let's see what this would look like configured to that task. Thankfully, this is a pretty straightforward task, and the manifest for this is not too difficult to comprehend. What we're looking at here under the spec, under scale target reference, pretty much the only line that you're going to need to change is what is the name of the deployment. The API version and kind should be straight up what you copy, just straight out of the documentation. Min and max replicas are straight out of the task. The horizontal pod autoscaler will always make sure that we are somewhere inside of that range. Under metrics, this may differ because who knows what they'll ask you to do on the exam, but we were told to make sure that for all the containers across this deployment's pods, that the average CPU utilization is around 50%. Notice that you can make a list of other metrics that you may also be asked to do, in which case, just copy and paste that section right there and just tweak it from like CPU to memory to a different percentage of utilization. It's probably going to be one of those two things. Now, if you're following along at home and you're trying to run this inside of your own setup, this is not going to work unless you have a metrics server installed inside of your cluster. So the fact that that is up and running right now looks good. Metrics server is required for kube control top commands to work, and it is also required for our horizontal pod autoscaler to work. Now, interestingly, you'll notice that the pod that is being tracked by the horizontal pod autoscaler is consuming a ton of CPU. That's well above the 50%. So what we're going to see wind up happening is that the total number of pods is going to increase roughly every 16 seconds or so, 15 seconds or so, as the autoscaler cranks up. That is, as soon as I made the horizontal pod autoscaler. So let's make that real quick. Yep, there we go. So it's firing up a whole bunch of new containers because the CPU is just screaming. So looks good. That may not happen on the exam, depending on how it's set up. But at the very least, it should increase to the minimum of whatever the HPA is set to be. Next, node affinity. So here we're being told, make a pod that shows up on only those nodes that has the label disk type SSD. And again, all this node affinity stuff that we're being asked to do, you can find inside of manifests in the Kubernetes documentation. Just go to the docs, search for node affinity, and in that first result, you will find a pod manifest that will include that node affinity part of its spec. Let's get this copied over and let's build it according to what the task is asking us to do. And there we go. You might be asked to, schedule any old pod, which is running any kind of image and is doing any kind of thing. It doesn't matter. But the one thing that we had to change is under match expressions, key, what's that first part of the label, operator in, and then list values, just what's the second part of the label. So SSD. So with this pod looking correct, let's get down and let's make it. And first, let us check and see which node it is that is actually going to have the actual label that we're looking for. So it looks like it's node 1. If we create that pod that we just made, we can check what node that pod is on. And looks like this got created on node 1. Once you get my big fat head out of the way, you can see that I am made it on node 1, which means that we definitely put this in the right spot. Let's move on to the next task. Let's talk about pod security. In this task, we're being told to enforce the restricted pod security standard on the namespace, restricted namespace. Pods in that namespace cannot have privileged access, host networking, or have any sort of elevated rights. So how are we supposed to know what the heck we're supposed to do here? What we can do in order to pull this off is you have to go to Kubernetes IO and you have to search enforce pod security standards with namespace labels. So what this is, and it'll be right at the very top, it'll show you that a namespace can have all those labels, and what that will do is that it will enable you to set those to a specific enforcement level. So let's point out the ones that we would need in order to pull this off, but all these are described inside of this page on Kubernetes IO. Now, what we're going to assume in this task is that namespace, restricted namespace, it already exists. And you can add and remove labels just from the command line with the kubectl label command, which I highly recommend that you become proficient with. So the label that we need, the key value pair, pod security Kubernetes IO /enforce equals restricted. So this will enable restricted mode. If you are told that you need to have a specific version of restriction, because it depends on what version of the exam that you're taking, then here's an example of a different label that you might use. And all this one is doing is that it's just setting what is the baseline of restriction that you're expected to apply. Again, that should be described inside of the task. And if it's not, just go with whatever version is inside of the documentation, because that's going to be up to date with whatever version of the exam you're taking. Now, it can be a heck of a thing testing this to verify that everything's working, but here's a pod that I just took off of the documentation that allows privilege escalation. That is one of the things we were told you cannot do when you have that restriction label. So if we try and create this pod, then this is actually an error that you should be happy to see. So hey gang, I scratched your back and we are covering all of these great tasks to prepare you for your exam. Could you scratch ours? Make sure you give this video a like, subscribe to our channel, and check out the description for a lot of great opportunities for additional training so that you can pass your exam. Next are taints and tolerations. The wording on this can be very different. You might be told something very cattly and snarkily. Make sure that pods can't be scheduled on a specific node, and then not mention anything about taints at all. But here it is explicitly telling us what it is that we need to do. Although you may be told add a taint that has a specific label, or add a taint that is of a specific taint type, and you may or may not be asked to create pods or edit existing pods that have appropriate tolerations. We're just going to do it this way so that you can see the whole shebang. Adding a taint is super easy with the kubectl taint nodes command. So we're supposed to taint node 1, and the last part of the command you're seeing here, dedicated equals experimental, that was the label I was talking about. It's a key value pair that may be provided by the task. Following the colon is what type of taint is it you're supposed to add. No schedule is the most common type of taint there is, and it's probably the one that you'll be asked to do. So should get an output that looks like that. Now let's create a pod that, even though that node is tainted, will still go and be scheduled on that node. So here's our pod. Nothing super sexy about it just yet, but here are the parts we would need to add in order to satisfy the tolerations part of this requirement. First, we want to make sure that it is going onto the correct node. Now, there wasn't anything in the rules saying that we needed to use node affinity to do this, so node selector could be an alternative, or node name and call it out by the specific name. You shouldn't be docked points if you're using equally valid non-specified means of choosing a node. As far as tolerations go, this is what we would need. Remember, when we put the taint on top of our node, the key value pair was dedicated experimental, and that the type of taint that it was no schedule. So long as we are matching what that taint is there, then we can set this as our toleration. By the way, we're assuming that the node in question does have that label in order for it to be selected appropriately. But if this did get assigned where it was supposed to go, if we were to get pods output wide and just check for our dedicated pod, we can see that it is running successfully on node 1, despite the fact that it was tainted. And if you want to check whether or not a taint has actually been placed on top of a node, check the description, and we can see right there it is tainted and we are tolerating it. Woo! This next one is rough. We need to deploy a stateful set named web with 2 replicas using the Nginx image. Each pod should have its own 1 gig persistent volume for address there. Ensure that stateful set pods have stable network identities and that persistent storage remains associated with the ordinal index, even if pods are rescheduled. So if we kill the pods and they come back, will they keep the same index number? And, cherry on top, create a headless service named web to facilitate stable networking for the stateful set. Oh boy! Thankfully, headless service just sounds scary, like headless horseman or so on and so forth. What we're making here is just a cluster IP type service that what makes it headless is that when you look at the cluster IP value, it is just set to none. And what we also need to do when we are making this is that we want to make sure that the service is selecting our stateful set pods. So the label app web is what we need to make sure are on the pods being made by our stateful set. This manifest is pretty nuts, so we're going to use Notepad++ to make this a little bit more parsable. So let's see why this stateful set manifest is going to solve what the task was asking us for. We've got 2 replicas, and we are pointing out the service by name, although we do still want to put the labels that we had under selector on that service on the pods that are being made inside of this stateful set. So for selector, remember the stateful set itself needs to identify which pods belong to it, so let's just keep it the same label, app web. Under template is where we're going to spell out what the pods made by the stateful set are going to look like. And any details you see in there are going to be taken from the task. So when we see those, we'll point those out. Let's first also point out that we are going to, because we want to make sure that this pods are being made with persistent volumes, here's how we are going to make that happen with a volume claim templates section. So if you're able to search that up in the documentation, you'll be able to find it and you'll be able to copy and paste that. So this template, which we're going to name www, so remember that, is going to basically describe, hey, what kind of persistent volume do you want for each one of these pods that we're going to make? So storage class, that's one from a previous task. We're going to say 1 gig worth of storage because that's what we were told to do. So that's all just persistent volume stuff. Even if you never use volume claim templates, shouldn't be too much of a reach. So that being said, let's crack open the template. So for all of these pods that are being made, remember, we wanted to make sure they all had that label so that the pods will be identified by the service and by the stateful set. For our spec for the pod itself, termination grace period seconds, all right, not a required field, but that was inside of the defaults when I copy pasted it. I'll just leave it in there. As far as our containers, here's where things are getting a little interesting. We're just going to assume a base Nginx container here. Let me shrink my big fat head. Remember that volume mount www is the name of our volume claim template that we made down below. So that's what's going to make sure that each of these pods are being made with persistent volumes the way we described them. And there we have it. We've created both of those objects, but always trust but verify. I'm always a big fan of using that watch command so that I can see changes to outputs like kubectl-get change in real time. But what we can see here is that those are our pods that are part of the stateful set, because I'm looking them up by their app web label. And if I wanted to check, are these bad boys getting storage like we asked them to, then we can see, boom, Web 01 and Web 1 are being bound to both of those stateful set pods. And what we should also see is that if we were to delete one of those pods, it's going to come right back. It'll have the exact same name as it did before, and it's going to connect to the exact same persistent volume claim / persistent volume like we did see previously. So run that command again. Still working great, which means we nailed this one. Task number 9, CoreDNS troubleshooting. DNS lookups are failing in the cluster. Investigate and repair CoreDNS. All right, so let's see what an example of the level of troubleshooting you may be expected to do for a task like this on the exam. You can see that, CoreDNS is hurting if you take a look in your kube system namespace, and you can see that the pod itself is in a crash loop backoff. We need to determine exactly what is causing that to be busted. If we were to describe the pod, we really wouldn't get a whole ton of information. But if we were to check the logs of that particular pod, then we may find something particularly interesting. That when I run this, it says, error during parsing unknown directive Kubernetes. All right. Looks like there seems to be a typo, but where could that possibly be located? If you're not familiar with CoreDNS, you should know that what makes CoreDNS desirable is that it is highly configurable. And chances are somebody done screwed up the configuration. That configuration is inside of a config map. So what we're going to do is we're just going to straight kubectl edit our CoreDNS config map. You may want to save this to a file and then make your edits to that if you want. But let's go ahead and crack this bad boy open, because I think we can be pretty confident we know what the problem is. And right there it is. Yup, somebody doesn't know how to spell Kubernetes. I get it. It's a tough word to spell. But if we save and quit, that will actually edit and make changes to our config map. And though it may be spooky, it's dead anyway. We are actually going to go ahead and delete that pod. That'll cycle it. It'll bring it back. And this time it should be rebuilt, this time with a config map that is not broken. So let's check and see how we're doing now. Awesome. Looks like it's up and running, which means that's hopefully one troubleshooting task that you are prepared for on the exam. Let's do another CoreDNS task. This one involves configuration. But wait, you telling me that there might be a configuration task and also a troubleshooting task, which means that if I couldn't troubleshoot, then I wouldn't be able to configure it, which means that I would miss out on 2 tasks instead of just 1? Yeah, welcome to the CKA exam. Anyway, cluster workloads need to resolve a custom domain internally. Configure CoreDNS such that any DNS query from my app internal returns the IP address 10.10.10.10. After configuration, and here they're throwing us a bone that pods in the cluster should be able to resolve my app internal to 10. So we are going to test that, of course, after we make these changes. Once again, this is a config map issue. All configuration changes are going to be made to the CoreDNS config map. And it may be different from task to task, but adding a resolution like this shouldn't be too hard to do. Now, you can add this anywhere inside of this core file section that you're seeing. I'm just going to slip it right under Prometheus with this section here called hosts. So 10, my app internal, that's exactly what the task was calling for. Fall through just means that, if that query fails, just move on to the next one. So it would be best practice to make sure that you include that. So once again, just like we did when we fixed this last time, if we save and quit, or kube control apply, if you made a copy of that and you're doing it that way, we now need to make sure that those changes kick in, which again is something that you do simply by deleting the CoreDNS pod. It will be rebuilt, but this time according to our config map. So that should do it, but how can we test whether or not this worked? Hopefully the exam throws you a bone and gives you something that will make it easier to test. But what this kube control run is going to do is it's going to temporarily create, then remove a pod that we're going to call DNS client. And what it's going to do is it's going to run BusyBox, which lets us run commands like nslookup. We're going to run an nslookup on my app internal. And what we get back from that after this gets created and finishes is that it is returning a 10. So this DNS is resolving just the way that we want it to. And now let's take a look at Helm. So what we're being asked to do with this is that we're going to be basically tasked to install something according to a specific chart. You'll be told what that chart is. It'll be up to you perhaps to find it, or it may be already locally, on your machine. Who's to say? We're going to just go with the worst case scenario. And while we're at it, we're going to use this to install an ingress controller because gateway APIs rely on those. So maybe installing Trafic is something you might be asked to do. So let's get down to the command line and let's see what it would take. So if you are being asked to add a repository, you will be given the link to where it is supposed to be. It's up to you to remember the specific Helm commands. So we're going to add that Helm repo. But once you've added a repo, don't forget to make sure that you have updated version of it. Now, remember what I said earlier that we're going to make this a little harder than what you might be asked to do on the exam, but consider this the command as we're about to install this chart. We're installing a particular release from a particular repository in a particular namespace. All those are things that, are fairly straightforward. It's that last option, set experimental Kubernetes gateway.enabled equals true. Now, I'm not going to run that command yet, but how could they, in good conscience, ask questions that would require crazy long options like that? Because they will, and because here is the expectation. You're not expected to, memorize those things. You are expected to be able to find those values and use them. That's why they let you have Kubernetes IO. You're expected to look stuff up. So the Helm show values command is going to show us what all can we declare. So much output, I'm not even going to try to scroll through it. Let's just grep here real quick. And inside of that first result that I get there, notice how it's saying that Kubernetes gateway enabled false. All right. So if we wanted to set that value to something else, then we would need to make sure that we do that when we are creating the actual chart itself. So one more time, here's the command. Install under that specific release name, that specific chart, and that specific namespace, which we do need to create. And what we're going to do with dot notation is experimental dot Kubernetes dot enabled. That was false. We want that to be equal to true. So when we run that, that should build, but with those specs that we asked for. All right, all created. And with a Helm get values, looking at Traefik inside of that namespace that we made, we can see that those have been set. Realistically, you'll be told what it is that you need to set, but I do want to prepare you for a worst case scenario. Task number 12 is Kustomize, and this is our circumstance. We already have some base manifests for us to play with inside of that directory you see there. What we need to do is that we need to use Kustomize to deploy a production variant of this app. So basically, take the deployment manifest that's in our base directory, but when we use Kustomize, it should add that label. It should prefix all resource names with prod dash, and the Nginx image tag should be 1.21 instead of the 1.19 that's already inside of it. So if we hop on out of this and we hop inside of that Kustomize directory, this is what we already have. That inside of Kustomize base is our deployment manifest. And you can see there's the 1.19 and all the other things that we're supposed to fix. And that customization with a K right there is just making a list of these are all the things that are available to be customized. So what do we need to do to satisfy the requirements of this task? All right, so when we're working with multiple directories, that can get pretty confusing. So up above my head, you can see a display of all the changes that we're making in real time. So in the same directory as the base directory, I'm going to create a new directory. Let's call it overlay prod. And inside of overlay prod, we are going to make our own customization.yaml file. And there are plenty of customization YAML files that you can find on Kubernetes IO that you can steal from. I certainly am here. First thing we're going to do is that we're going to call in all the resources inside of base. So ... means down one directory and then, or up one directory, then down into base, which is where deployment.yaml is located. Since we want to make sure that all those resources are being made with prod at the beginning of the name, that's what this name prefix line here is going to do. And then basically it's almost like a find replace is how I think of Kustomize. That when we see these like parts of the manifest, labels, pairs, environment, production, all right, we want to set those values to that. And under images, when we see wherever the key is Nginx, we are going to want the value to be 1.21 instead. So what that'll do is that if we save and quit on out of that, then we do need to make sure that we are writing out this next command correctly. So we're going to do a kube control apply, but not -F like you're used to, -K for Kustomize. And we are going to specifically apply what's inside of that overlay prod directory that I had made earlier. So let's run that. And as a result of having done that, if I do a kube control get deployments, we can see, there you go. It has made that deployment with the prod prefix in front of it. That's good news. And if we were to describe that deployment and kind of pick out what changes we were supposed to make to it, then you can see that the label environment production is on it and that it is using Nginx version 1.21. So we have succeeded at yet another task. Kubernetes exam tasks that focus on networking are difficult in the best of times, but API gateways, which you may not be familiar with at all, are a guaranteed ask on the exam. And this is the point where I would say that if you are out of your wheelhouse and this is stuff that you need to know but don't understand and want to get it learned quickly, then check out the link down inside of the chat. where you will find an excellent deal for Alta 3 Academy, where we are going to teach you all of this stuff, give you an environment to practice it in, and we'll beat the pants off of anybody else and our competitors. So let's go ahead and take a look at this. Your cluster uses the Gateway API for ingress traffic. A service named Web Service is running in the default namespace on port 80. A Gateway API compatible controller is already installed, which will be the case on the exam. And a Gateway class named Example Gateway class is available in the cluster. What we need to do is that we need to use API resources to expose that web service externally on port 80. So API Gateway is just the new hotness when it comes to networking. We need to make sure that that's routed to the hostname web.example.com. So let's break that down. All right, so here we've got our gateway manifest. And you really got to mind your P's and Q's when it comes to gateways and namespaces and getting all of your things connected here. So notice that our gateway, web gateway, is in the namespace default. And if you look at the very bottom where it says allowed routes, it is namespaces from same. So we're only able to connect these if they are sharing a namespace according to that particular line. We're listening on HTTP, port 80, at the hostname web.example.com. So these are all just copy-pastable straight from the task itself. But what you're also going to need to make is an HTTP route object, which we're looking at right here. Again, same namespace, very important. But notice that our parent refs is web gateway. That's the gateway that we made prior to us looking at this manifest right here. And under rules, you can see that under backend refs, here's where all these objects are starting to tie together. So we set up our web gateway using the controller that was already installed. But our HTTP route is what's going to connect web.example.com to the service, web service, with its port of 80. So that service, web service, and then the deployment that web service is pointing to, that's already created. Those are already running inside of our cluster, in case you're wondering why we aren't building those. But let's create both these objects here. All right, so with those two manifests created, we need to figure out how we're going to test this. Now, on the exam, I'm sure they're going to give you a curl command that you could actually use. But if you're doing this in your own system and you need to figure this out, here's what you need. First, find what is the node port that's being associated with your Nginx gateway, is what we're using inside of this demonstration. And what we are also going to need to do is to get one of the internal IP addresses of one of our nodes. It doesn't matter which. And what we have there is that we are sending a curl request to web.example.com at the IP address for one of our nodes, at the node port for our gateway. And when we run that, we get back our classic welcome to Nginx. Is there ever a sweeter sign? Which means that our gateway is properly configured and we are accessing this deployment through the hostname. Looks good. And now for our last task, we are looking at pod admission. So the number one admission controller that we're going to be talking about for this is limit ranges. And that's exactly what we need to build in order to satisfy this task. So in a specific namespace, enforce default resource limits and requests for containers, so that if we're making a container with no CPU or memory requests or limits, assign a default value for CPU and memory and a default limit value for CPU and memory. And in the same breath, we're also being told that any container in that namespace cannot request more than 500 megabytes worth of memory. We can knock all that out in just one manifest. So take a look here and we'll see how we're going to build that. All right, so here's our manifest where we're going to make our limit range. And let me make sure you can see the very tippy top of it there. We're going to apply this limit range to our limit test namespace. And right there is where we are going to say, hey, if you're going to make a pod with a container inside of this namespace, then if you don't say what those values are going to be for requests and limits, then down there you can see this is where we are setting the limits and we are setting the default requests. And that's copied straight out of Kubernetes IO. We're just changing around the values to reflect what's being asked of us by the task. But what we're also being asked to do here is that we are being told, hey, let's have a max value as well. So max memory, 500 megabytes. If we also needed to set a max value for CPU, we could do that as well, but that wasn't what we were being asked. But this all looks good to me. So let's save and quit and run a kube control apply on the lr.yaml. And there's a couple of different ways that you can check if this went the way that you were hoping it went. You can describe the object that you made. That's pretty readable, and you can see from that. Or you can describe the namespace itself, limit test, which has that exact same thing down at the bottom, but that's a little more satisfying because you can see that that is attached to the actual namespace itself. Woo, gang, this new CKA exam is no joke. Swallow your pride and accept that you need help in order to pass this exam. What you can do is you can check that link down inside of the description and check out Alta 3 Academy, where we have up-to-date labs as well as videos featuring me that will teach you everything you need to know to pass the CKA, the CKAD, as well as 14 other courses, many of which have their own certifications. Plus AI coaching as well as mock exams. It's everything that you need in one place. Best of luck on that exam, everybody, and take care. I'll see you next time.